Hey, this is Jason Molesky. In this example, let's take a look at some situations and determine whether or not we can safely use a t-star critical value to calculate a confidence interval for a population mean. Suppose we want to estimate the average GPA of students at our school, and so in doing so, we randomly select 50 students from classes you take. This histogram displays those GPAs. Well, in this case, we cannot use t. Although this histogram is roughly symmetric with no outliers, the random sample of 50 students was only from your classes and not from all students at your school. So we shouldn't use these data to calculate a confidence interval for the mean GPA of all students at the school. How much force does it take to pull wood apart? This figure shows a stem plot of force in pounds required to pull apart a random sample of 20 pieces of Douglas fir. Can we use t-star in this situation? Well, actually, no. If you look carefully at the stem plot, we see that the graph is strongly skewed to the left with a few possible low outliers. Therefore, we can't a value from a t-distribution with degrees of freedom 19 in this case. Now suppose we want to estimate the mean SAT math score at a large high school. This figure is a box plot of the SAT math scores for a random sample of 20 students at the school. Can we use a t-star critical value here? Well, in this case, we'd say yes. The distribution that we have is only moderately skewed to the right. There are no outliers present. So based on what we've learned about the t-distribution, we should be safe in using t-star to construct a confidence interval. For some additional practice in determining whether or not it's safe to use t, try exercise 59.